Hello, in this video I'm going to solve the following gold level problem, one variable calculus, on the topic of improper integrals. This is a problem from India. The following integral from 0 to infinity, x minus 1 all over, the square root of 2 to the x minus 1 times ln of 2 to the x minus 1 dx converges to. Pause the video at this point and give it a try to see which one of the given following options is the correct answer to the problem. Okay, the first thing I will do here is to introduce a new variable. So let me call that variable u, and I introduce it as a square root of 2 to the x minus 1. So what I want to do, I want to rewrite this integral only in terms of my new variable u. Okay, so to this end, I raise both sides to power 2, so u squared becomes 2 to the x minus 1. Then of course it is natural to differentiate both sides now, so it becomes 2u du, and the right hand side becomes 2 to the x ln of 2 times dx. Okay, I want to rewrite everything in terms of u. So one of the things I have to get rid of is dx in favor of du, or an expression in terms of u. So this motivates me to divide both sides of this equality by this expression, and I get dx. So dx becomes equal to 2u divided by 2 to the x ln of 2 du. But this is still not good enough because I see still 2 to the x there. I want to get rid of all x's. So then this motivates me to go back here and move this 1 to the other side to be able to write 2 to the x in terms of u. If I do that, then it becomes 2u. If you don't mind, let me write ln of 2 on the left as a factor, multiplied by 2 to the x becomes now u squared plus 1, and then I have du. Okay, so that's good. That's du. So I have it now in terms of u. The next thing I want to do is to get rid of this x. Again, I go back here and I calculate 2 to the x from here. So 2 to the x becomes u squared plus 1. Then I take ln from both sides, so it becomes x ln of 2. On the right hand side becomes ln of u squared plus 1. And then because I am looking for x, I will find x to be ln of u squared plus 1 divided by ln of 2. The next thing I have to take care is the new limits for my new variable. Okay, so x, according to the problem, goes from 0 to infinity. This would then imply that u goes from, if x is 0, I put 0 here. So 2 to the 0 is 1. 1 minus 1, 0. Square root of 0 is 0. So again, u becomes 0. And of course, if x is infinity, then 2 to the infinity becomes infinity. So the final will get. So coincidentally, the limits are left intact. Okay, so if this integral that I want to calculate, I call it I, so my integral I can be written in this form. Integral, still it goes from 0 to infinity. Instead of x here, I can write this expression. So this becomes ln of u squared plus 1 divided by ln of 2. And then I have minus 1 all over. Instead of square root of 2 to the x minus 1, I can simply put u. And instead of this expression here, I can put u squared. And instead of dx here, I can put this expression in. So let us do them. So this becomes u ln of u squared. And then here I will have 2u divided by ln of 2 multiplied by u squared plus 1 du. Okay, so let me simplify this a little bit. So this 2 goes to the back, and it gives me 2u, which will be cancelled by that 2u there. Okay, So let me write it here exactly below this expression. So this expression can be written as 2u ln of u, and then you see that these 2u here and that 2u there are cancelled. Okay, but now I want to get rid of this ln of 2 here, so I rescale this fraction by multiplying everything by an ln of 2. So the numerator, this ln of 2 will be cancelled. This becomes ln of 2. There will be another ln of 2 here, which will be multiplied by this ln of 2, gives me ln of 2 squared. Then I pull it out from my integral. So integral I becomes equal to 1 over ln of 2 squared integral from 0 to infinity. I have ln of u squared plus 1 minus ln of 2 all over ln of u multiplied by u squared plus 1 du. Okay, so it seems that we haven't done something useful here. Of course, we have changed this integral to this integral. It doesn't look that much simpler unless you realize there is a trick sometimes for these kinds of integrals, that the limits are from 0 to infinity, and somehow this change of variable is not very evident, very clearly seen, but it needs a little bit of experience. At least if you have that experience, you will be able to give it a try. Okay, what I want to do, let me call this part of integral j, and I want to do j by introducing a new variable again. So I'll introduce variable t to be 1 over u. So from here, u becomes 1 over t, then it means that du becomes minus 1 over t squared dt. Okay? And now what I want to do, I want to change everything in this new integral, to be able to write it in terms of t. Okay, so what can I do? So first of all, remember that u goes from 0 to infinity. This would then imply that t goes from, if u is 0, if I put 0 here, t becomes infinity, and if u is infinity, t becomes 0. So this goes from infinity to 0. So this means that the integral j becomes integral from infinity to 0, and then ln of, instead of u squared, because u is 1 over t, u squared becomes 1 over t squared, and then I have plus 1, and then I have minus ln of 2, and the denominator here, instead of ln of u, I would write ln of 1 over t, and instead of the other expression, I would write 1 over t squared plus 1, yes? Why? And then I have multiplied by this du at the end would be replaced by this expression. So it becomes minus 1 over t squared dt. Okay? So now what happens, the first thing is that I will use this minus sign to change the order of these limits to the natural order. Okay? So this becomes integral from 0 to infinity. So I have dropped that minus sign. But now look, this t squared will be multiplied here, so this will give me t squared, and this gives me plus 1. And this one can be written as minus ln of t, yes? Okay, so that minus sign, I pull it out. So this becomes again minus ln, and here I take the common denominator, so this becomes t squared plus 1 divided by t squared. And then I have minus ln of 2 divided by ln of t multiplied by t squared plus 1, and then I have dt here. Okay. Again, it might look a little bit of a strange to what we are doing, but be patient a little bit. So this becomes minus integral from 0 to infinity And in the numerator, what can I do? I can write it as ln of t squared plus 1 minus 2 ln of t, and then I have minus ln of 2 divided by ln of t times t squared plus 1 dt. Okay, but now you know that the integration variable is a dummy variable, so this means that if j is equal to this integral, in this integral I can change t to any other name including u itself. And then I will multiply this minus sign inside the numerator. So this becomes minus, this becomes plus, and this becomes plus as well. Okay, so this becomes equal to integral from 0 to infinity 2 ln of t plus ln of 2 minus ln of t squared plus 1, and then divided by ln of that should be u. So let me do both things in one go, otherwise we have to write a lot. Okay, so I changed this name to u as well. So this becomes u, and then this is also u squared plus 1, ln of u times u squared plus 1, and then du. So what does it mean? It means that if this integral is j, this integral is also j. So now I add j to j, so it becomes 2j is equal to the sum of this integral and this integral. Okay? But then it means that I can add the integrands. The denominators are the same, so I have to add the numerators. When I add the numerators, this and that will be gone. This and that will be gone. 2 ln of u will be left. So this becomes 2 ln of u divided by ln of u multiplied by u squared plus 1 du. And this is du, sorry. This is du. Okay? But now you see that this ln of u and that ln of u are gone. Of course, the limits are also the same. It goes from 0 to infinity. And then what happens? These 2 and that 2 will be cancelled. So finally I get that j is equal to integral from 0 to infinity du divided by u squared plus 1, which is arctangent of u going from 0 to infinity. But arctangent of infinity is simply pi over 2, and arctangent of 0 is 0. So extremely amazing problem, you see. It was a little bit complicated, yes, but finally it worked out. And then it will teach you a lot, you know. So here, this j is pi over 2, but my goal is to calculate I. So I is this factor multiplied by j. So it means that finally the answer to the problem is 1 over ln of 2 squared multiplied by pi over 2. So that is the correct answer to the problem. Which, if we go back, you see that this is the correct answer. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.